Just gotta pull these things up and.
Okay. So, what did you think of lesson 11?
I did it pretty late last night, and I had a harder time with that than lesson 10. I thought lesson 10 was easier.
Is Nico talking?
Yeah. Can you not hear him?
No.
Uh-oh.
You're kind of soft.
I
I can hear you, but you're kind of soft.
Okay. Can you hear me better?
Yeah.
Okay. It's this
Oh, there we go. That's
kind
much
of
better.
microphone in my headphones.
Were there certain things you guys wanted to go over or questions?
I couldn't do anything as far as like Excel or SPSS goes, so I guess I'll just figure out how to do that when I go to the math lab on their computers.
Okay. You don't have that on your computer?
No.
Oh.
So those answers that have anything to do with that, I'm just gonna be SOL, I guess.
Okay.
I had a question with, so did you watch the videos that he has?
Yes.
That Excel document that he pulls up, is that something that we have access to?
That is that he pulled up. I think he was working in SPSS.
Okay.
But we do have. That's why I thought this was easier because it was just putting numbers in. If you go back to the math lesson in lesson 11, the online book,
Yeah.
there was a link for. Let's see if I can open it up. Um, the program to use in Excel and the program to use in SPSS. See if I can find it real quick.
Okay.
And so I just opened that up. So it's in step 4, just right at the very beginning, if you go down the different steps at 3.1, and in step 4, there's Excel instructions.
Is that where it says verify the requirements that have been met?
And mine's a blue box, and it says the Excel file needed for this analysis is quantitative inferential procedures. And I just clicked on it, and it opened up another window in my browser, and then it had different links to the tools.
Mm-hmm.
So then you want the quantitative inference procedures. Did you see it?
I don't see it. Is it, how far down is it about?
Did you find the what I was talking about in the online?
Yeah, I see the SPSS instructions, but I don't see the Excel one.
Mine has Excel instructions right above the SPSS. So in step 4, verify the requirements have been met.
Okay. Right above that?
So it says give the test statistics and its value, instructions for conducting a test for one mean with sigma unknown, and then right underneath that there's a box that has Excel instructions, and underneath that is a box that has SPSS instructions.
And you're in lesson 11?
Yep. You don't have that?
I don't see it. Because I'm in step 4, and you said the requirements for creating confidence interval for a mean with sigma unknown are the same as the requirements for this procedure when sigma is known, right? And then below that it says 4.1.1 requirements.
No. So go back up to, okay, so 3.1. Body temperatures revisited. I think you're down too far.
Okay. Body temperatures.
So at 3.1,
Okay. 3.1.
did you find that where it says body temperatures?
Yeah.
And then underneath that, there's step 1, the
Uh-huh.
little bullet point, step 2, step 3, step 4 is where you should have the Excel instructions.
Yeah, I see an SSPS one, but I don't see
That is really weird
cell one.
because I have both.
Yeah, I can only because I could not find that, and so I don't know.
Tamara, did you use the Excel or did you use SPSS?
I used Excel.
Huh. Well, I know the school has SPSS and they can at least show us how to use it. My husband's used it before, so I know it works, and it's not as bad as or as intimidating as you might think. I find it harder to use Excel.
Well, they give instructions for both, so I think you can do either one.
Okay.
Yeah.
All right. Anyway, that was my question.
But yeah, what he was using in that video was SPSS, and that you should be able to access that when going through that program.
Okay. All right. Well, should we go through the homework?
Yeah. The part 2 or the
Yeah, part 2.
Oh. So then we're in individual preparation.
yeah. So actually, number 7 was the start of part 2 because we were supposed to find the mean and the sample standard deviation of these 15 numbers.
Okay.
Okay, well mine looks different because number 7 is talking about the null and alternative hypothesis. Is that correct?
No.
Huh.
I have.
Okay.
Yeah. It's so right above part 2, right? Is what you're talking about.
Yeah. So the in part 2, Vanessa, it starts with the study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. Is that what you have?
No.
Are you in lesson 11?
Yeah.
Just the individual preparation?
Yeah, well, what's weird to me is it's got 4 different options.
Because when you put down PDF, it's the same thing really. One's the answer key, one's the assignment. You just put it in 2 different formats.
So then it should be the same. I don't know why it's not.
Yeah. So you either, the preparation assignment online, you put it in a doc or a PDF. And I believe they're the same.
Okay, what What did it start with?
Yeah, they're the same. Part 2 is the study of National Association of Realtors.
Oh, okay. I found it. No, it's different than the other one. The other one just looks different on my computer, and I don't know why it scrambled everything up, but it
Oh,
did.
maybe it just doesn't like the format.
Probably.
I opened
But
both of them and they were the same. Maybe it's just the format.
yeah. No, I have it here.
Okay.
Oh, sorry. Morning.
Okay, so then the sample mean, which is on number 7, is just the mean of those. How many is that one?
15 numbers.
15 numbers. Okay.
Yep.
So what I ended up doing is I just opened up an Excel document and plugged all those numbers in, and
That's
then
what
just
I
did
did.
the equation. Okay, so I got the 46.733333.
Yeah.
Okay. And then the standard deviation I had 8.827.
That's what I had too.
Okay.
So the first question then is just asking, in order for it to create this 95% confidential t-interval, has to fit into certain requirements. And it's similar to what we did in lesson 10, I think. It has to be a simple random sample from a population, and the X bar are normally distributed.
Okay.
So it either has to be a normal distribution bell curve or have a high sample size.
Okay. That makes sense. Okay, and then so now we have to create a 95% confidence interval.
Yes.
Okay.
I don't remember the formula for that. Wait, maybe I have it. The t equals
X bar minus U divided by the standard deviation over N. Well, S over N, anyway.
Is the sample standard deviation, right?
That's what the formula was. Yeah, it's S over the square root of N.
so then for this it would be t equals. Wait a minute, I lost my numbers. $47 minus 46.733 divided by 8.827, which is divided by the square root of 15, right? Wait, no, that's not right. We have to have our 95% in there somewhere. I think I have the wrong formula.
No, I think that's right, because the t, doesn't the t replace the z-score? Is that what he was saying? I don't remember.
Um, I don't know. I feel like the material in the online textbook focused a lot on how to do it. Okay, so I think it is. Because this is we would have to do the plus and minus because we want two numbers. When you're doing with a confidence interval, we're saying that we're 95% confident that we're in between these two numbers, right?
Yeah.
So if you look at, where was I? 3.2 step, now I just lost it. Hold on. No. So at 4, confidence intervals, there's a formula for when you know the standard deviation, and then underneath it is a formula for when you don't, and basically you're just replacing the z with a t.
Right.
And we're using the sample standard deviation and not the actual standard deviation.
Yeah.
So the formula that I said earlier is not the right one. So it's the x plus or minus t.
I'm reading this directly from the text. It says to construct the confidence interval with
That's the one.
standard deviation not known, we replace the population standard deviation with its point estimate s. So it's still the same one. The appropriate distribution is a t rather than a z, so we replace z with t. So the confidence interval when standard deviation is known is x bar minus t times s over n, or x
Square
plus
root it.
divided by s divided by square root of n.
Yeah.
So it's not the t equals x bar. It's actually the x plus or minus t times s divided by the square root of n.
So then in this case, it would be 47 plus, I forget the 95 is the 1.96 times 8.827 divided by the square root of 15.
And then so the 14 degrees of freedom, that's where you got the 15, right? Because it'd be just the 14 plus 1.
No. The n is just the number.
Okay, gotcha.
Degrees of freedom is the number minus 1.
Gotcha, yep. Got it.
Right? So in this case, we use the actual number, right?
Yes. All right, did you guys get answers?
Yes.
I have 2 where I should probably need 1. So I'm working on it.
So the bottom part of the question, though, the t-score for a 95% confidence interval for the t-distribution with 14 degrees of freedom is 2.1448. What do we use that for?
I don't know.
I'm trying to find it in the text, like something.
You know what? I think, perhaps. So, okay, this is what, so Z is the Z-score, where we get the area of the, that's where we got the 1.960, but the T, we need to use the 2.1448,
Okay,
I think is the difference in the formulas.
gotcha.
Does that sound right?
Yeah, that makes more sense.
I'm gonna recalculate it because I'm gonna try something else and see, compare it. So.
So that didn't change my answer a whole lot.
I don't think it would have, because I did it earlier with the Excel program.
Uh-huh.
It was different, but not a whole lot different.
Okay. So for the lower, I got 42.112, and for the upper, I got 51.88. Is that what you got?
No, that's what I got when I just now figured it, but that's not what I got when I wonder. So how do we know what the X bar number is? Is it the 47 in the equation, in the program, the description, the 47 years, or is it our mu, 46.733?
That's a good question.
That's what I don't get.
I think it's the 46.773. Because if I do that number, then I get 51.613. And 41.85.
That's what I got when I did it on the, but I don't know. I don't know
Yeah, so
which number.
I think it's the 46.773 for this equation.
Because the X bar is the sample mean, I think, is what we need to remember.
Yeah.
Okay.
Is that what you got, Vanessa?
Yeah, that sounds close, although I think I'm doing it wrong. I'm trying to make sure that my answers are actually being calculated correctly.
That's, I mean, because I checked my answers when I worked through the problems, I checked them with the answer key.
Uh-huh.
So I Sometimes I just get confused which number goes where.
Yeah. So for number 2, did we even use the 95% anywhere? We didn't, right?
We did, because at the very bottom of the problem it says the t-score. So we're not using a z-score, we're using a t-score. So it told us the t-score for a 95% confidence interval is 2.1448.
Okay.
So
So
we
then
What
that's the
answers
same
did you
thing.
get on that one? Just to double check.
Which one?
Number 2.
41.8 and 51.6.
Yeah, I just opened it up to check that. It's right. So whatever you did.
So whatever we did, do it again for number 3 because it's the same thing.
Yeah.
Exactly. All right. Did you guys finish?
I had to open the probability applet to get the number for 99%. So it's
No, you
loading.
don't, because you're using the t distribution that's in the problem.
Yeah, we used the 2.9768.
Oh, okay. Go on doing what you're doing. I got it wrong.
So for 3, I had 39.95
That's what I got.
and 53.517.
Yeah.
Okay, sweet. Did you get that formula, Vanessa?
Um, no.
So it's the x bar plus or minus t times the sample standard deviation divided by
Over
the square
n.
root of n, square root of n, yeah. So that was the 46.773 plus or minus that t-score that they give us, the 2.9768. And then the sample standard deviation was 8.827 over the square root of 15 was our number.
Okay, and you guys are rounding those up?
The answer?
Mm-hmm.
It
Yeah.
doesn't say specifically on these questions. A lot of times it says to the nearest hundredth, but
Yeah. It doesn't tell us that though.
no. And then question 4, it's the same thing. They just want you to, instead of doing the calculations by hand, to do them using the program.
Okay. So I need to open up SSPS.
was this. People get cards in 10 to 14 business days, but here's their network number, network health number.
Yeah, hold on.
That one. It's just the regular place, right?
Dr. Wigo. Yeah.
Oh, set up Dr. Wigo.
When you take her, could you, all of these 3 kids need a new vitamin prescription? And it can just go to Target Pharmacy.
Actual vitamins or
Like their
fluoride?
fluoride vitamins. And then,
Fluoride or fluoride and vitamins?
yes, that's what they've been having. Both.
Okay.
And flu shots. At least just get her taken care of. So, if you want to schedule appointments or just take them, maybe we should take Abigail and Louise.
We do it for free at Target.
It's for free at the
I guess that's true.
doctor's office.
That's what I'm saying is we don't have to schedule anything. Just
Yeah.
I got mine.
I'm not
Yeah, right.
taking Abigail though.
Who's taking you?
I don't know. Wait, did you get it open, Nico?
Cool.
Yeah, that was really easy.
Yeah, isn't it?
Oh my gosh, yeah.
You
So
put the
41
numbers in and everything's there.
Yeah, 41.8, 449, and 51.6218.
Yeah. Did you do it for both?
No, how do I change it? How do I change the confidence interval? You know?
I don't remember how to do it on SPSS. There should be just a box where you just change it from 95 to 99. Do you see where?
Yep, I think so.
Because that's all you're changing. Everything else stays the same.
Yeah. Let's see if I can change it.
I'm looking through the instructions, but I don't see. There was a tutorial video on going over the steps for SPSS too. Does it not, the box that says confidence level, if you click on it, will it let you type in something different?
The box that says confidence level?
Yeah. On SPSS, when are you in the sample?
Yeah, so like where it says one sample test?
Yeah. Is there somewhere where it shows the 95?
Yeah, so I double clicked it and changed it to 99, but I think I just changed the number. No, it stayed the same.
Yeah, I don't know.
I don't see it.
Okay, by default, a 95% confidence interval is shown. To find other confidence intervals, go to Analyze,
Okay.
then Descriptive Statistics, and then Explore.
I'm there.
Move the desired variable into the dependent list. Then press the Statistics button on the right of the window. Change the percentage next to confidence interval for mean to the desired confidence level, then press Continue.
Okay. So I go to Analyze,
Uh-huh.
Descriptive Statistics, Explore. Put that in the dependent list, and then on the right, okay, there we go.
Press the Statistics button.
Oh, there we go. 99, continue. Okay. And there it is, 39.948 and 53.518.
Yeah. So we should have the same numbers that we had for number 2.
Oh, that was nice of them.
We're just doing them out by hand.
Okay, sweet. Well, that was easy enough.
All right, you still there, Vanessa?
Yeah, my husband's just stepping out, so I had it muted.
Oh, okay.
Still listening.
So going on to number 5 then. How does the margin of error of the 95% confidence level compare to the 99% interval?
So the 95 is smaller.
So basically your margin of error increases when your confidence level increases. So they'll both go up.
Okay.
Okay, so number 6, this is the last one, and it's just working through each steps of what we've done in the lesson.
Okay.
And it's actually some of the same numbers. It's the same numbers we already had, the list of 15 at the beginning of part 2.
Uh-huh.
So rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average of age 47. Use the 0.05 as your level of significance. Follow the following sequence steps. Fill in your answers at each step. So state the null and alternative hypothesis is for A.
So then the null is just whether or not the national average is 47.
Yeah, so the null would be U equals 47.
Okay.
And then the alternative is that it does not.
Perfect. Okay. And so here's where we get the 46.73 minus 47.
For B.
Yeah.
So that's the T, right? The T equals X bar minus M divided by sample standard deviation divided by square root of N.
Yeah.
Okay, that's why I was getting my formulas mixed up.
Okay, so I got -1 or -0.118. Yeah.
Yeah, that's what I got.
Okay.
Okay, and then you can also check it by, putting stuff into the software.
Okay.
Um, and then state the degrees of freedom.
Which is just 15 minus 1, right?
Yeah, so it's going to be 1 minus the number, so it's 14.
To compute the p.
And then use the software to compute the p-value. Do you know how to do that on the SPSS?
Is that through? I don't. I'm gonna look really quick.
I don't see where it shows the p-value on SPSS.
Yeah, it looks like. So you have to go through and double click on Sigma 210. Yeah, I'm not sure on this one.
Me either. I found it in Excel, but I can't figure out how to do it in SPSS.
Yeah, I don't know.
So I got on the Excel the p-value of 0.908.
Okay.
Which that is greater than our level of significance.
Okay.
So that means we would fail to reject.
Okay. Okay, so then G would be that there's not enough evidence.
Yeah.
All right. Should we do the test now, or are we gonna wait?
No, I think we were going to do it now and then